First, page number 10. Mention the question and along with the page number, so it will be convenient and better in sequence. So when it is in sequence, it is easy to discuss. Question 7, A, 3 and B. So in this question, the archer fires the arrow horizontally from a height of 1.5 meter above the ground. Calculate height above the ground at which the arrow strike. So the archer is there. And he's 1.5 meter at a height of 1.5 meter and he use an arrow. We have to find like what height above the ground this arrow hits the target. That's a question. So basically what we will do first, we will find what is the height or change in the height for the point where the arrow is released and the point where it hits the target, and we'll subtract from 1.5 because 1.5 is a total. So we will subtract this height from 1.5, and when we subtract from 1.5 we will get the height above the ground. So for this part we have to use the previous values. As I mentioned, the arrow is fired at a speed of 36 meter per second towards the target, which is 15 meter away. So first we will find like what will be the height or change in the height when this will cover 15 meter. So for this part, as we know, he fire horizontally with the speed of 36 meter per second. This is a horizontal speed. The vertical speed is 0. So we can use equation of the motion. But before using the equation of motion, we should know how much time it will take to hit the target. So we have the formula, speed is equals to distance over time. So time is equals to distance divided by speed. So distance is given 15 and speed is 36. So 15 divided by 36. That will be 0.4. So 0.41 seconds this arrow will take to hit the target. Now we will find how much height or what will be the change in the height from the point where it is released. So we can use equation of motion. We can use h is equals to or s is equals to ut plus half et square. But what is the initial speed? Initial speed is 0. Initial because it's fired horizontally, so there is no vertical speed. So initial vertical is 0. And whenever we substitute or use equation of motion, we always substitute the horizontal vertical component because vertical component is having expression. So because the u is 0, so this whole factor will be 0. So this will be half. Acceleration is due to gravity and t square. So h is equals to 1 by 2. Gravity is 9.8 and time is square, which is 0.41 square. So 0.41 square multiplied by 9.8 divided by 2. So we will get 0.82 meters. So this is a height when this arrow hit the target. So this is a height which is covered by this arrow. But in the question, they did not ask, they asked the position or the distance of arrow from the ground. So the point where it was released, that was 1.5 meter. If it is 1.5 and the arrow covered 0.82 meter from a point where it is released, so how much is this height? So just we will take the difference. It will be 1.5 minus 0.82. So that will be the final answer. Is it clear? The height above the ground. Then explain how your answer to part A would affect if the archer stood closer to the target. So if the archer stand closer to the target, like example, this is a trajectory which is followed by the target. If archer is closer or the target is closer to the archer, like example, I move the target or the archer move toward the target. So what will happen? The arrow will hit. You can see, like I simply change the position. Like if I just draw the trajectory of the or the path of this arrow, it is not exactly horizontal. It will start to deviate. So this was a trajectory event. So if archer is closer or the target is closer, so what will happen? The arrow will cover a small distance or it will strike greater height above the ground. Is it clear? Question 3B2 and 3. In the question, basically what happened, like a soft mint sweet is there, was dropped in a bottle. So when a soft mint sweet is dropped in the bottle, a fluid or the liquid will come out and it will follow a projectile motion. So basically what they're asking, they're saying in the question, why the value which we will calculate might be higher than the true value or might be lower than the true value. So the kinetic energy basically. So give a reason why your value of a kinetic energy might be higher. So kinetic energy is half mv square. We know the speed at which it is coming out, and this is our assumption that all of the mass, because the total mass of the content before the experiment was 2.24 and total mass of the content after the experiment is 0.79. So the difference is a mass which travel from one place to another. But maybe what happened, not all of the mass or not all of the liquid transfer to that same distance. Some of the liquid fall closer to this bottle. So why your answer will be higher than the true value? What could be a reason? So the mass of the liquid, some of the mass of the liquid remain or does not come out. Or the second thing is because the speed which we calculate, the speed at which it is coming out, it is 7.5 meter per second. But maybe some liquid is coming out smaller or with a slower speed. This is the highest speed which we consider, but some of the liquid is coming out with a slower speed. That's why the value which we will calculate and the value which is the actual one might be different. Our calculation value will be higher and actual value will be different. And the second part they're saying, explain why your value of kinetic energy might be lower than the true value. Like true value is higher, but our value of the kinetic energy might be lower. Because what happened, as a liquid is coming out from the bottle, so as the liquid is coming out from the bottle, it is coming out with a speed of 7.5. But that speed of 7.5 may be, that is the reduced speed due to air resistance or friction of the bottle. So actual speed will be higher, but when it is coming out from the bottle, the speed decreases due to air resistance or the friction of the bottle. That's why when we calculate the kinetic energy, because we are considering this 7.5 is a maximum, but maybe this 7.5 is not maximum. This is the smaller speed. Maybe the actual speed might be higher, but that is reduced due to the air resistance. Is it clear? Like why our value might be higher or lower than the true value. Then question 12, page 12, question 10 AB. Mangonel is a type of catapult used to launch a projectile such as rock. A student make a working model. Add the handle, it as the handle is turned, the arm pulled back by the string, and this increases the tension in the rubber band. And when the string is released, the rubber band causes the arm to move up and launch the projectile uh, from a bucket. When the arm is hit the crossbar, suggests why the rubber band is used to support the arm. So what is the reason? Because what happened, rubber bands can store energy. So if it can store energy, what it increases? It increases the, basically, like when you stretch the rubber band, the energy is stored. And when you release, it will transfer the energy back so the object can move or object can have different energies. So mainly what is the reason why not directly it is just thrown, why a rubber band is used? So rubber band can transfer the energy or rubber band can store energy. So first when we stretch the rubber band, it will store energy. And when we release, it will transfer energy. Like example, what happened basically, look, this is a model, mangonel. So first it is pulled back. So when it is pulled back, so what happened? It will stretch the rubber band. So it will stretch the rubber band when it is pulled back. And there's a bucket here. There's a bucket and the bucket is having a stone. So when we release, the rubber band return back, transfer the energy and convert into potential. So the rock will have a projectile motion. State the energy transfer that occur when the string is released. So when we transfer, like what is the change in energy whenever an object is stretched? So when object is stretched, it will have elastic strain energy. And what happened? This elastic strain energy, as it will move to higher position, it will turn into potential energy and kinetic energy as well, because it will at certain reach a certain height, it will have potential and it start to move, so it will have kinetic. So basically elastic strain energy converted into potential energy and kinetic energy. Then the student varied the angle to the vertical. This is the angle to the vertical. Like when the angle is 15 to the vertical, say this is a release point. Then angle is 30 degrees to the vertical. then it is 45 degrees to the vertical, and it is 60 degree to the vertical. Say this was 30. So a small change in the angle, then it was, sorry, 15. The first value was 15. Then it is double like 30. Then it is 45 and 60. And you can clearly see when the angle is 60, the range, the maximum range is greater. What is the reason? Because when it will release, return back, because when it returned back to the vertical flow position, it will release the stone. Here, because the object is stretched a smaller amount than like the energy which is stored in the string is a smaller amount of energy stored in the spring. That's why it's less kinetic energy, so it will have a shorter range. But when we stretch the rubber more and release, so when we release, it will return to the vertical position and release the projectile, and this projectile will have a longer range as compared to when released at 40. So it 40 will have greater range. When it releases 60, 60 will have much greater range. So basically what happened, explain why the range increases as the angle increases. So basically what is happening as we are increasing the angle, so basically we are doing like greater amount of energy. When greater angle is there from vertical, it means greater internal energy or elastic strain energy. So when we release, greater amount of kinetic energy will be there, or the projectile will have a higher initial speed or launching speed. That is why it will have a greater range. Is it clear? Is it clear, this part? Uh, but this angle is from vertical. This is a bit different thing. Look, when a projectile is launched, an angle with horizontal is given. Like this angle was 15. So at 15, it if in same initial speed, at 30, then 45 will have a maximum range, and at 60, when it is launched at an angle of 60, so the range at 60 and the range at 30 will be same. At 45, the range will be maximum, but that is when angle is given with horizontal. This is not the angle with horizontal. Basically, this is a change in the angle from vertical plane, or it shows how much the rubber is being stretched. Like because the vertical position, this projectile is being launched. So the change in the angle, it's 15 here. So smaller change in angle, less amount of internal energy or elastic strain energy, so less kinetic energy. If we stretch more, like we made it 30, so greater internal energy or elastic strain energy, so greater kinetic energy, greater range. At 45 and then 60. So 60 will have the maximum one. Why? Because the rubber is stretched more. As the rubber stretch more, it means initial internal energy is more or elastic strain energy is greater. That's why greater amount of kinetic energy, so higher speed. Is it clear? This is not about the angle with horizontal. It is the object is launched by basically here the change in angle is representing how much energy is stored or how much internal or elastic strain energy is there. Then page 13, part B. So a student replaces a projectile with a smaller mass. State why increase the range. So what will happen? Because both cases, when the launching angle is same, so it will have the same initial speed or same kinetic energy, not same initial speed, it will have the same kinetic energy. Like example, say this is a vertical plane, the crossbar, where when it hits the crossbar, the projectile is released, and we change the angle 30 degrees for both. So when we change the angle 30 degree, the initial elastic strain energy is same for both. So same elastic strain energy because the rubber is stretched. But what happened? Here we are using, say example, 1 kg. Another case we are using 2 kg. So both cases, when the projectile is launched from this point A, so both cases the projectile will have the same kinetic energy. So if the kinetic energy is same, the formula is kinetic energy is half mv square. The kinetic energy is same, but what happened? So kinetic energy is constant, 2 is constant. So what is the relation between mass and speed? They are inversely. So if object is having a smaller mass, it will have a higher speed if the kinetic energy is same. Both will have the same. Like example, if I say this will have 200 joules of kinetic energy, the other will also have 200 joules of kinetic energy because the same elastic strain energy, initial elastic strain energy is same. But what happened here in this case, the object which is launched is lighter, so small mass, so it will move at a higher speed. So greater initial speed will be there. It means it will have a greater range. But for object which is heavier, so kinetic energy, because we want the same result, half mv square. So if m is more, the speed square will be less. That's why the kinetic energy, that's why the speed at which it is launched is less. So it will cover a shorter range. Is it clear, this part? The next part they're saying suggests a modification that would increase the range of a projectile. Like example, we want basically what is happening, like this is a crossbar. So this is a crossbar. I'm drawing a vertical line, but crossbar. So there's a crossbar, and what we did, we use a rubber band. So we stretch this like from the vertical position, we attach a rubber band, so a rubber band is a stretch. So when we release, this rubber band will transfer the elastic strain energy to the potential and kinetic. And at this position, because this arm cannot move further, so the projectile will only launch and it will cover certain distance, and that is refers to range. But in a question, we need, they're saying how we can increase the range, like so that it can cover greater distance. So how to increase the range which this projectile will cover? So what we can do, basically mass is the one thing, like changing the mass, and the second, but already that is done in the previous part. So we can change the speed. And how we can change the speed? Because if one rubber band is there, it stored less amount of energy. But if two rubber bands are there or three rubber bands are there, they will store greater amount of energy. So as they store greater amount of energy, greater amount of kinetic energy will be there, or the launching speed will increase, which increase the range covered by the projectile. Is it clear? Is it clear, this part? Then page 18. Page number 18, question 14b. Okay. Look, actually this question is interrelated. So I will discuss part A as well. Two projectiles are launched at position O at the same time, with both projectile have traveled the horizontal distance. A projectile A is launched with a velocity UA at an angle of theta, and projectile B is launched with a velocity 45. Show that UA may be expressed in UB. And both projectile have traveled the horizontal distance O to P. So when both travel the same distance, so it means both will have the same range. And time is also same. So means we can say range of projectile A is same as in that time, like at that time interval. At time B. So that is equals to range B. And range is a distance. Distance is speed multiplied by time. So UA multiplied by T is equals to UB multiplied by T. But what is UA and UB? That is actually the horizontal speed. So for UA, the angle is not known. So it will be UA cos theta. But for UB, the angle is known, and that is 45. So it will be cos 45. And cos 45 is 0.707. So if you need UA will be equal to 0.707 UB divided by cos theta. In the second part, explain why the path of the two projectile to be as shown in UA is more than UB. Because what happened? Look, both have the same range. So basically what happened? If two objects have the same range, what is the formula for range? Range is horizontal speed. So UA cos theta into T. And this one will be UB cos 45 into T. So why the for the path of two projectile as shown, UA should be more than UB. We want them to have the same range. So, and the time is also same interval, time interval. So basically what happened? Why? Because the launching angle of UA is more. So if launching angle is more, the horizontal speed, because what happened? Cos 0 is maximum and cos 90 is 0. So when the value of the theta increases, the value of the cos theta decreases. So relation between theta and cos theta are inverse. So as the value of the theta is increasing, the value of the cos theta will decrease. So launching angle of UA is more. So cos theta value is decreasing. So the UA should be higher. Is it clear? As you can see, the launching angle of UA is more. As the launching angle is more, so cos theta will be less. If cos theta is less, so UA should be higher, so that we will have the same range. And in the next part, on the axis below, sketch a graph for vertical component of the velocity against the time for a motion of projectile A and projectile B between O and P. And you may ignore the air resistance. The vertical motion is only affected by, like, air resistance is there, but it is also affected by the gravitational force. Acceleration due to gravity. So acceleration due to gravity is constant. If acceleration due to gravity is constant, then what happened? The velocity will have a constant rate of change. Now, as you can see, for UA, the vertical component, because the vertical component is given by sine theta. The vertical component of A and vertical component of B is also UB sine theta, which is 45. And as you know, when we increase the value of the theta, what happened to sine theta? The sine theta also increased. Like example, as like sine 30, sine 45, sine 60, as the angle theta is increased, the value of the angle is increased, the value of the sine theta will also increase. So as the value of the sine theta increases and UA is already higher, because UA is already higher than UB, that already we worked out in the previous part. So this is smaller value, theta is increasing, so value of sine theta is increased. So means the vertical velocity of A should be higher than vertical velocity of B. That's why it is, and it is obvious because the height which is covered by A is higher as compared to height covered by B. So when we sketch a graph for velocity and time, a constant acceleration means constant slope should be there. So it should be a straight line. When the projectile is launched, so vertical velocity increases and then the vertical velocity decreases. So basically for the same time interval. But the second thing, for A, it is continuously rising. So as it is continuously rising, it does not have a negative velocity, it is still rising, but a constant slow. So start with a higher value, and it is the acceleration velocity will decrease as the velocity decrease. So you can see the vertical component of velocity is decreasing at time t, because what happened for A, it is continuously rising, even it does not reach the maximum height. If it reaches the maximum height from O to P, then what kind of graph I should plot? I should plot a graph in this manner. But because what happened, still it is rising. That's why I did not complete the graph when time is t, the vertical velocity, because vertical velocity at maximum height is 0. But in this case, the vertical velocity will not be 0. But what happened to B? For a B, it rises and then it returned back. So when it is rising, the vertical velocity decreases. When it is coming back, the vertical velocity increases, but it is in opposite direction, so negative. So parallel lines should be parallel to each other. Why the lines should be parallel to each other? Because the acceleration is due to gravity. Both will have the same acceleration due to gravity. Is it clear? This graph. Then page 21. The actual horizontal distance traveled by the ball is affected by air resistance and the upward force caused by the spin as it moves through the air. Explain how each of the forces are acting, like affecting the range of this. So basically how the forces affects the range. If the projectile If there's due to the spin, if there's an upward force, first thing, if there's a air resistance, if air resistance opposes the motion, so it reduces the time of the flight. If the like if a projectile remain for a longer period of a time, it will cover greater distance. But say you launch a projectile, it's not affected by air resistance. This is the trajectory which the projectile follow. But when you launch another projectile with the same speed, but air resistance is acting, so it will not remain in air for a longer period of a time because air resistance is opposing its motion. So the time of the flight will decrease. If the time of the flight decrease, the range will also decrease. But if there is an upward force, that upward force, like if you launch a projectile when there is no upward force, and if you launch another projectile with upward force, so upward force reduces because more like there's an upward force. In this case, the acceleration is there and air resistance opposing. So if there is an upward force, it reduces the deceleration or acceleration due to gravity. So as the acceleration or deceleration decreases, so this projectile will remain in air for a longer period of a time. So it will cover great. If a projectile remain in air for a longer period of a time, so the distance traveled by the projectile or the maximum height reached by the projectile, both will increase. So basically, if you change the time of the flight, if you increase the time of the flight, both the maximum height and the range will increase. If you decrease the time of the flight, the maximum height and range will decrease. Is it clear, this part? Then page 22. Question 18a. State the significance of a negative value of the height for. So basically what this negative value is showing, it is showing it hit the ground or below the launching point. Like example, a projectile is launched. If it fall on the same height, it means the height of a ball when it reaches the goal. So what it shows, it is showing like example that the projectile, like if I say a goal is say 5 meters away. So if this was a goal post, the height of the ball when it reaches the goal, that is 1 meter above the ground, then 2.8 meter, 4.7 meter or 0.78 meter. So what it represents, basically it is representing that ball bounces or the ball will hit the ground before reaching the goal. That's why the significance of a negative height. Negative height is only representing that like minus 0.78 meter. What it shows like if you launch a projectile, when it reach that position, it will be negative 0.78 meter below the, or it is 0.78 meter below the launching point. Is it clear? This part.